So last meeting, I started with just introduction about this course. Hydrology and hydraulic course is talking about water. So let's start first with chapter number 2, some basics about fluid mechanics. We have some fundamental concepts about fluid mechanics. The first one called surface tension. Surface tension results from a different molecular bonding condition at the free surface compared to bonds within the liquid. What is the meaning of this point? If you have tube like this one, and this tube is filled with water, so probably we have bonding between water and the surface of the cylinder. This cause the water looks like this in the tube. So in water, surface tension results in properties called cohesion or adhesion. Cohesion enables water to resist slight tensile stress. Adhesion enables it to adhere to another body. So surface tension is a result due to the properties called cohesion or adhesion. Let's watch this video to see what is the meaning of this phenomenon.
For just $67, you can make as many videos as you want, and you never need to pick up a camera.
Today on Sci Guys, the surface tension of water.
Welcome to Sci Guys. I'm Ryan.
And I'm Teresa. And today we're doing surface tension of water.
And we're going to use pennies. But unfortunately, they don't make them in Canada anymore.
We need to steal these. Surface tension is the tendency of the surface of a liquid to resist external forces such as gravity.
The equipment you're going to need for this episode includes a bowl full of pennies or dimes,
A glass,
measuring cup,
and if you want, some food coloring. While we're not working with anything hazardous today, it's always a good idea to wear an apron or lab coat to protect from spills and splashes.
The first step in your experiment is to take your glass and a measuring cup full of colored water and fill up your glass until the water reaches the absolute top brim of the glass. It should look like a slight dome of water.
The next step is you want to take your penny and very gently drop it in the middle of the glass. If the surface shakes, you want to give it time to settle down before dropping another one.
Continue to add pennies to your glass until water spills over the edge. The water in your glass should now be in a dome shape that rises above the rim of the glass. Let's look at this experiment a little closer. Water is an amazing substance. One 8-ounce cup of water contains in the neighborhood of 7.91 times 10 to the power of 24 molecules of water, which is around this many molecules of H2O in every cup. This puts into perspective how very small water molecules are. Each water molecule is made up of one oxygen atom and 2 hydrogen atoms in a V shape. Water molecules want to stick close to each other. The force that keeps them within close proximity to each other is known as cohesive force. Cohesion happens between all liquid molecules, but because the molecules inside our glass pull on each other equally in all directions, they generally cancel each other out. However, since the surface of the water has air molecules above it instead of water molecules, the cohesive bonds between the surface molecules are much stronger than those inside the glass. These stronger surface bonds generate a net inward force pulling the surface molecules toward the middle of the glass, keeping them all together. This strong inward force causes the molecules on the surface to contract and to resist being stretched or pulled away, creating an almost elastic tension at the surface of the water, known as surface tension. When we add pennies to our water glass, the water level rises, and the inward pull of surface tension keeps the water from spilling over the edge, generating a convex dome that rises above the glass. The dome will continue to rise as we add pennies until the amount of force pressing down on the dome by gravity is greater than the surface tension generated by cohesion, causing water to spill over the edge of our glass. Water will continue to spill out of the glass until the force of gravity and surface tension are equal. If you look at the dome of water from the side, you will notice that it has rounded edges at the rim of the glass and a flat top. The flat portion of the dome is created by gravity pushing down on our dome of water.
That's it for surface tension of water. Thanks for watching.
If you enjoyed this episode, let us know in the comments below and subscribe for future episodes.
So, surface tension is a phenomena that enable the water not to spill over the glass tube because we have a cohesion between the water molecules will prevent this water from spilling out the glass. We will have this dome shape of water. Also, if you have any piece of metal in contact with the water, we will see this cohesion, or I'm sorry, this adhesion between the water molecules and the piece of metal. All of these phenomena due to the effect of surface tension. So, cohesion enables water to resist slight tensile stress. Adhesion enables it to adhere to another body. By the way, surface tension is called sigma equal force divide L. If you have a surface of water and you have a piece of metal in contact with the water surface, this surface of metal with length L, so we have a force between the water and the surface of the metal, this force called F. Based on the phenomena surface tension, we have a relationship between this length and this force and the surface tension. Surface tension equal force divide L. So sigma surface tension, F surface force at the interface between the water surface and the metal, and the L is the length of interface. You can try it if you have a cup of water filled with water and you have a piece of coins, quarter or whatever. Please make contact between this coin and the water surface. You can find we have a contact force in between the surface and the two surfaces. So this force F with the length of the coin and the properties surface tension, you can get a relationship sigma equal F divide N. We have example number 1. We have a full width is a surface tension experiment with a length equal 10 centimeters. So L equal 10 centimeter. If mercury is the fluid, we don't have water, but we have mercury with surface tension of this liquid equal or given by 0.52 Newton per meter. What is the maximum force? We are looking for force that can be applied without breaking the membrane, the contact between the liquid, which is mercury, and the surface of the film. So we have a relationship between surface tension and the applied force and the length, sigma equal F divide L. So make sure you make your unit consistent. Sigma equal 0.52 Newton per meter equal the required force, which is unknown, divide L, which is 10 centimeter. You can figure out the value of F, but make sure you make your units consistent. This term is Newton per meter. This term is 10 centimeter. We need to convert one to the other one, meter to centimeter or centimeter to meter. I'm gonna convert 10 centimeter to be 0.1 meter. At this moment, I can say the required force will be 0.052 Newton. This force will maintain the contact between the surface of the mercury and the surface of the film. It's very easy, very direct problem about surface tension. We have only one relationship connected between the surface tension and the applied force and the length of the contact between the two surfaces. Then we can figure out the missing term. Any question? Guys, do you have any question? If you have any question at any time, let me know, please. The second phenomena called, or fundamental concept called Keblerity. Keblerity, in a very simple way, if you have a liquid in this container and you put tube which is very, very, very thin, due to the concept of Keblerity, we can expect this liquid to rise in this tube with distance h. This tube is very thin, very little diameter of this tube. So we can expect rising of this liquid inside this tube with distance h. Probably if you have a different fluid like mercury, this one probably water. Probably if you have a different liquid like mercury and you put the same tube, we can expect dropping in the liquid with distance h. So we have a phenomena called Keblerity. Keblerity is a property of a liquid that results from surface tension due to the effect of surface tension, in which the liquid rises up or depressed down in a thin tube like this one, or this one here is rising up, dropping down based on the type of the liquid. If adhesion predominates over cohesion in a liquid, as in water, the liquid will wet the surface of a tube and rise up. However, if cohesion predominates over adhesion in a liquid, as in mercury, the liquid does not wet the tube and is depressed down. The amount that water rises in a tube depends on the temperature. It's not a big deal. However, we have a relationship between the height of liquid in the Keblerity tube and the surface tension and the diameter and the unit, specific weight of the liquid and the angle made by the liquid with the wetted tube beta. This relationship H equal 4 sigma cosine beta divide gamma D. As I told you, if you have very thin tube in a water, for example, we can expect rising of this liquid H. How can I figure out this value of H? H equal this equation. This equation is function of the surface tension of this liquid, the angle made between the liquid and the surface or the tube, the wall of the tube, gamma unit weight, the unit weight of the liquid, D is the diameter of the capillary tube. Also, if you have a different fluid like mercury, we can expect a drop in the liquid inside the tube. This drop H can be figured out using also this equation, H equals 4 sigma cosine beta divide gamma D. So this phenomena is related to surface tension. To remind you just a little bit, what is the difference between cohesion and adhesion? Cohesion enables water to resist slight tensile stress. Adhesion enable it to adhere to another body. So based on the relation between cohesion and adhesion, we can expect the liquid will rise or the liquid will depress down in the tube. Based on this concept, we can figure out the amount of this height inside the tube using this relationship. By the way, beta is the angle between the surface of the liquid and the wall of the tube. This is the angle beta. Between the surface of the liquid and the wall of the tube, here is the angle beta of the liquid. This is the meaning of angle made by the liquid with the wetted tube wall. Example. At a particular temperature, the surface tension of water is 0.073 Newton per meter. So sigma, which is the surface tension of water, 0.073 Newton per meter. Under ideal conditions, the contact angle between glass and water is 0. That's fine. Beta equal 0. The contact angle. A student in a laboratory observes water in a glass Keblerity tube. We have water and we have Keblerity tube. This Keblerity tube with a diameter D equal 0.1 millimeter. Can you tell me what is the theoretical height of the capillary rise? We can expect rising of water in this tube by H. What is the value of H? What is the height of the capillary rise? Okay, we can go back to this relationship. H equal 4 sigma cosine beta divide gamma time D. I will cover it soon. Gamma for water is known, equal 981.0 Newton per cubic meter. I will discuss this later today. So gamma water is given, or you are familiar with this value. Anyway, let's do it. So the capillary height H equal 4 sigma. Sigma is given, which is the surface tension 0.073 times cosine beta, which is the contact angle between the water and the glass, which is 0, cosine 0, divide gamma 9810. Diameter of this tube is given 0.1. Please, before using your calculator, you have to make sure that the units are consistent. So sigma in Newton per meter. Gamma of water Newton per cubic meter. Diameter is given by millimeter. I believe everything is good. This one is good. This one is good. This one is good. This one is good. Both of them are consistent. Newton meter, Newton meter. But your diameter in millimeters. We need to convert. What do you think? To convert millimeter to meter, or convert this meter and this meter to millimeter? Which one is better? Which one is more easy? I think convert this one to meter. So 0.1 divide 1000 will be in meter. Then I can figure out the value of H. This value will be 0.297 meter. So the water will rise in this tube by 0.297 meter or 29.7 centimeter. So please make sure you are reading the problem carefully and you can decide which equation you are going to use. If you have capillary tube and you need to figure out the capillary height, you are using this equation to figure out the value of H. If we are looking for the surface tension or the contact force or something like this, we are looking for the equation for surface tension, sigma equal F divide L. Any questions so far? Do you have any questions so far?
No, sir.
Okay.
You want the review?
No questions.
Yeah, thank you. We have another example. This example was included in the exam for last year. We have two capillary tubes are placed vertically in an open container of water. One tube has a diameter of 2 inch, not millimeter, it's 2 inch. And the other one with a diameter of 1 inch. In which tube will the water rise higher? This problem is giving a container with water. And we have two capillary tubes. This one and this one. The first one with a diameter D equal 2 inch. The second one with a smaller diameter D equal 1 inch. Can you tell me which one of the two tubes will the water rise higher? I believe both of them will have H, This one with diameter D1, H1. This one with diameter D2, H2. I would like to investigate which height is bigger, H1 or H2. So guys, what do you think? Which one the water will rise higher? With diameter 2 inch or diameter 1 inch? What do you think?
Diameter 1 inch.
1 inch? Yeah, I agree. None? What you mean by none, Zach? Zach, what you mean by none? Oh, none means no question? I'm sorry. Yeah, looks like no question. Anyway, thank you, Marcus. With 1 inch. Okay, I believe if the diameter is more thin, the height will be higher. But we need to prove this concept mathematically. Let's try. Let's try to prove this mathematically. We agree that H equal 4 sigma cosine beta divide gamma time D. Let's do it for the first diameter. So H1 equal 4 sigma, I don't know what is the value of sigma, cosine beta, I don't know what is the value of beta, divide gamma, I don't know what is the value of gamma, but I know the diameter for the first tube is 2 inch. I agree with this. Let's do it one more time for tube number 2. So the height H2 equal 4 sigma, I don't know what is the value of sigma, cosine beta, I don't know, gamma, I don't know what is the value of gamma, and the diameter of the second tube is 1 inch. So if you would like to divide H1 by H2, just divide. So 4 sigma cosine beta divide gamma time 2. Divide 4 sigma cosine beta divide gamma time 1. Guys, the problem said we are putting the two tubes in the same container with the same liquid, which is water. Same liquid means sigma can cancel this sigma. We have the same surface tension because we have the same liquid. If you have the same liquid, gamma will cancel this gamma, the same unit weight for the water. And the cosine beta will cancel cosine beta. Both of them are the same because we have the same liquid in the same container. So finally, this relationship can be 1 divided 2. Numerator of a denominator is denominator. Denominator of a denominator is numerator. So the final result, H1 divided H2 equal 1/2. That means H1 equal 1/2 H2. That means H1 is smaller and the H2 is bigger. Because H1 is 1/2 of H2. If H2 is 5 centimeter or 5 inch, H1 will be 2.5. If H2 equal 4, H1 will be 2. If H2 equal 10, H1 will be 5. So which one is smaller? Which one is bigger? H1 will be smaller, H2 will be bigger. So the tube with the thinner diameter the water will rise higher than the other tube. I can prove this mathematically using these steps. One more time. I figured out expression for H1, another expression for H2. I divided H1 by H2 and I cancel many terms. Why you cancel these terms? Because we have the same liquid, the same water. So same water means the same surface tension, the same beta, the same gamma. I cancelled all these terms together. Finally, I found H1 divided H2 equal 1/2. So I can figure out which one is smaller and which one is bigger. This example, we have one time like this in the first exam last year. What else? Yeah, this slide is very important. I need you to understand it carefully. I believe in the high school you learned some of these concepts. We have something called density, which is rho equal mass divide volume. Mass divide volume. For any material, we have something called density. This density can be expressed by rho equal mass divide volume. We have another expression called unit weight or specific weight. Which is gamma equal weight divide volume. Guys, if you go back to the first principle, what is the relationship between weight and mass? Weight equal mass time G. So I can say gamma equal rho time G. Why? Because with gamma equal weight divide volume, rho equal mass divide volume times G. If you multiply mass by G, you can get weight. So weight divide volume equal weight divide volume. So the relationship between specific weight and density, gamma equal rho times G. Just to remind you, G called acceleration of gravity. Do you remember that? Do you remember the value of this term? Probably 9.81 meter per second square if you are talking about SI unit, or equal 32.2 feet per second square if you are talking about US unit. So this is the summary of this slide. We have something called the specific weight. If you would like to write something from here, density equal mass divide volume, specific weight, gamma equal weight divide volume, the relationship between weight and mass, weight equal mass times G. So the relationship between unit weight or specific weight and density, gamma equal rho times G. G is the acceleration of gravity equal 9.81 meter per second square or 32.2 feet per second square. So specific weight, density, and the relationship between specific weight and density. By the way, G can be called acceleration of gravity equal 32.2 feet per second square or 9.81 meter per second square. Make sure you are understanding this one. Any question? Any question? We have another expression here called specific gravity. Make sure you are not confused between these two expressions, specific weight and specific gravity. To make it clear, specific weight, which is gamma equal weight divide volume. We have another term called specific gravity, which is SG, specific gravity, equal gamma divide gamma water. Gamma for any material, divide gamma of water, I can figure out the specific gravity for this material. By the way, for your information, and you have to keep it in your mind, gamma water equal 9,810 Newton per cubic meter, or I think 64.5 pound per cubic feet. I think this term is here. Yeah, keep it in your mind, 64.5 or 0.2. I cannot remember. Anyway, 64.2. Okay, 64.5 pound per cubic feet. I'm not sure about this value, 64.2 or 64.5. Anyway, so we have three terms: density, specific weight, and specific gravity. Make sure you are not confused between specific weight and specific gravity. Specific weight equal weight divide volume. Specific gravity equal gamma of this material divide gamma of water. The relationship between specific weight and the density, specific weight equal density times g, g called acceleration of gravity, 9.81 meter per second square, or 32.2 feet per second square. Any question? Okay.
No questions for me.
Yeah. Example number 4. We have a can. This can has a diameter of 4 inch and 6 inch height. Is filled with liquid if the net weight is 2 pounds. Weight of the liquid equal 2 pounds. What is the specific weight of the liquid? Okay, we understand that specific weight of this liquid or any liquid or any material, specific weight gamma equal weight divide volume. I understand that the weight is given 2 pounds of this liquid. How can I figure out the volume of this liquid? Okay, the volume is inside this can. Can you tell me what is the volume of this can? If you can figure out the volume of this can, I can figure out the volume of this liquid. Volume of a cylinder equal area of base divide height. That's right. The base is circle. So pi divide 4 times diameter square. This is the area of the base. The height of this cylinder is 6. I believe I can figure out the volume. This volume will be pi divide 4 times 16, which is 4 square, times 6. This number will be 75.4 inch cube. It's a volume. So please put your volume here, 75.4 inch cube. Your final answer will be 0.0265 pound per inch cube. So the specific weight of this liquid will be 0.0265 pound per inch square. So the idea here, you have to understand what is the meaning of specific weight, which is gamma equal weight divide volume. I'm looking for what is the value of weight, what is the value of volume, divide both of them together. You can figure out the specific weight. One more example. We have a container measuring 10 centimeter by 20 centimeter is filled with a liquid. If the net weight is 450 Newton, what is the specific weight of the liquid? We have something missed here, I believe. Container measuring 10 centimeter by 20 centimeter is filled with liquid. 10 centimeter diameter and 20 centimeter height of this container filled with liquid. If the net weight is 450 Newton, what is the specific weight of this liquid? The same steps. Gamma equal weight divide volume. The value of the weight of the liquid, 450 Newton. Volume of this container, it looks like cylinder with diameter 10 centimeter and the height 20 centimeter. So the volume will be area of base by divide 4 times 10 square time h, which is height. I can figure out the specific weight by divide 4 times 10 square times 20 divide 4. This value will be 0.286. What is the unit? This one in Newton, this one will be centimeter cube. Your final specific weight will be Newton per cubic centimeter. Okay. Guys, just I remembered here, I'm sorry for this mistake. The specific weight of water is 62.4. I'm sorry, 62.4. Okay, 62.4. Anyway, example number 5. What is the specific gravity? Wow. Please make sure you understand these terms carefully. Specific gravity, Sg of kerosene, which has a specific weight of 7.85 times 10 to power 3. 10 to power 3 Newton per cubic meter. Okay, specific gravity for any liquid or any material equal gamma of this material divide gamma of water. That's right. If you go back here, specific gravity for any material equal gamma of this material divide gamma of water. Okay, gamma of this material, which is a specific weight of kerosene, equals 7.85 times 10 to power 3 Newton per cubic meter. What is the value of gamma water is not given in the problem, but you have to remember it. Gamma of water has two values, 9,810 Newton per cubic meter or 62.4 pound per cubic feet. Which one I'm gonna use? I'm gonna use the first one because your units are Newton and millimeter cube. So 9,810 Newton per cubic meter. Your final answer will be 7.85 times 10 to power 3 divide 9,810. Your value will be 0.8. Anybody can tell me what is the unit here? What is the unit? Any answer? Gamma material divide gamma water. This one is Newton per meter cube. This one Newton per meter cube. Your final answer 0.8. What is the unit? No unit. It's dimensionless. Thank you. Thank you, Melvin. Yes, no unit. It's dimensionless. We don't have dimension. If you go back to my notes, the specific gravity of a liquid is the ratio of its specific weight to that of pure water at standard temperature and shouldn't be confused with the specific weight. Specific gravity is dimensionless. No unit for specific gravity. One more time. What is the specific gravity of a material called SAE30 oil? It's a type of oil. We are looking for a specific gravity for this oil. Okay, specific gravity equal gamma for this oil divide gamma of water. What is the given? Which has this oil has specific weight gamma oil? How much? 57.4 pound per cubic feet. That's fine. So gamma oil is given. If you divide gamma oil by gamma water, I can figure out the specific gravity. Okay, what is the value of gamma water? Gamma water is 62.4 pound per cubic feet. 62.4 pound per cubic feet. Okay, go ahead and divide 57.4 divide 62.4. Your value will be 0.92 dimensionless. We don't have units. The last concept in this chapter, which called viscosity. Viscosity can be described as a fluid, the resistance to shear force. Shear force. If you would like to feel with viscosity, okay, try to put your hands in a water and make friction by your hands together. Try to put your hands in oil, food oil, for example, and then try to make friction by your hands. What is your feeling? What is the difference? I believe oil will cause more resistance, more shear resistance, more friction between your hands, more feeling. So viscosity of oil will be bigger than viscosity of water. So viscosity can be described as fluid, the resistance to shear stress. Anyway, we have two types of viscosity. The first one can be called absolute viscosity. The second one can be called kinematic viscosity. We have a relationship between the two viscosity. By the way, absolute viscosity can be called mu, this term. Kinematic viscosity can be called nu, this term. The relationship between mu and nu equal mu divide rho. Rho is the value of density. So nu is the kinematic viscosity. Nu is the absolute viscosity. The relationship between both of them, the value of density. Just to keep in your mind, we have two types of viscosity, absolute and the kinematic viscosity. We will discuss this later in chapter 3 and 4, I think. We have an experiment here. If you have two plates, plate number 1 and plate number 2, and we have a liquid in between the two plates, the distance between plate number 1 and the plate number 2 is delta. The area of plate number 2 or plate number 1 is A. This area is A. And we have a force pushing plate number 2 to be moved with a velocity V. One more time. We have fixed plate with velocity 0, fixed plate. And we have another plate is moved under the effect of a force F, and this plate is moved with velocity V. The distance between the two plates are delta, and we have a liquid or fluid in between. That means we have shear stress. We have shear stress between the two plates. This shear stress equal F divide area. This force divide the area of this plate. If you divide for this force and this area, you can figure out the shear stress between the two plates or between the fluid and this plate. This shear stress equal mu time V velocity divide delta, which is the distance between the two plates. Mu is the absolute viscosity. Mu is the absolute viscosity. So if you have this experiment in a problem, you need to understand we are looking for what is the distance between the two plates, delta, what is the applied force, F, what is the area of this plate, and what is the velocity of the movable plate. Then we can figure out the shear stress between the fluid and the plate equal force divide area, and this shear stress can be used to figure out the absolute viscosity or the velocity. We have an example here. The viscosity of a fluid is to be determined using a sliding plate viscometer. This experiment called sliding plate viscometer. The plate area, which called A, equal 0.16 square feet. The separation between plates, which is delta, equal 0.07 feet. We have a force of 0.0002 pound moves the upper plate at a velocity V equal 6 feet per second. What is the absolute viscosity mu? Guys, if you go back to this experiment, we have two plates with a distance delta in between, and the upper plate under the effect of a force F, which is moving with a velocity V, then we can figure out the shear stress, and this shear stress will help us to figure out the value of mu. Okay, let's start. What is the value of shear stress tau? Equal F divide area. What is the value of F? 0.0002 divide area 0.16. This value will be 0.00125. Bound, this one in bound, this one in feet square. So this one will be bound per feet square. Then tau equal mu times V divide delta. Shear stress equal 0.00125 equal mu. I'm looking for mu. What is the velocity? 6 feet per second. What is the separation? What is the distance between the two plates? 0.07 feet. Before starting to figure out the value of mu, do you think your units are consistent? This tau in pound per square feet? I believe yes. Everything in feet, everything in pound, everything in second. So the only unknown is mu. So I can figure out the value, which is 0.00145. And I can figure out the unit. It should be pound second. That's right, I think. Per feet square. Pound second per feet square. Okay. Any question? The last example in this is week, we have a liquid has absolute viscosity mu equal 2.2 times 10 to power negative 5. It weighs 45 pounds per cubic feet. What is its kinematic viscosity? The raw value for this liquid, 45 pounds per cubic feet. Do you remember the relationship between kinematic viscosity and absolute viscosity? Nu equal mu divide rho. That's it. Nu equal mu divide rho. So nu equal mu 2.2 times 10 to power negative 5 divide rho 45. I can figure out the value of nu will be how much? Oops. It will be 0.0000489 or equal 1, 2, 3, 4, 5, 6 0.489 times 10 to power negative 6. So guys, this chapter we can expect, I believe, 2 problems in the first exam. So make sure you can understand. As I told you, this course is open note. What you mean by open note? You can open your own note during the exam. That's fine for me. But the only problem that most of the student is facing, they cannot figure out which problem, which file I need to open during the exam. It's a big issue. So please try to print these notes, try to put your own notes, your own solution to be ready for the exam. Okay? Do you have any question for chapter number 2? Any question?